Hello, this is Mary Pat, feeling a little better. So what I'm going to do in this lecture, I'm going to try to keep it short, but I'm going to be talking about the assignment, specifically the part with the Fibonacci numbers, which I screwed up last Tuesday, and so I'm going to show what I screwed up. What I'm going to be using for this is the Really Big Hints file, okay? That is on the first VBA assignment, so please get that and let's get ready to go. Okay, so I have the code open. This is going to look different than what you've seen in class because I'm using my MacBook Pro here, which is using OS 10 instead of Windows on my ThinkPad. So let me show you again how we get here. When you're in your regular Excel setup, again, this is the Mac layout, so here are the tabs up here, and we are lucky in Mac world that we get to keep our menus as well. So I have the developer ribbon open, and then I'm going to go into the VBA editor. Now, the VBA editor looks very different in Mac compared to Windows. I have the Project Explorer open, and remember, if I want to choose what I want to see, code, that's these windows over here that have the code. Then we have the Project Explorer, so we already have that open. And I want the immediate window. And remember, the immediate window is where I can type in some code and it will run the moment I hit enter. Okay. Yeah, the Mac message boxes are not as snazzy as the Windows ones. Okay. So last Tuesday, I had put together a function for the Fibonacci numbers, and that's what I'm calling here the screwed up Fibonacci. Okay, and this is how it was written out. Just as a reminder of how you define a function, generally we're using public functions, so that means you can call it from within the spreadsheet, from other code, and that kind of thing. If it's private, then you could only call it within this particular module, and we're in problem 2 module right now. Okay, so the way it was set up, if n equals 1, then screwed up Fibonacci num equals 1. If n equals 2, screwed up Fibonacci num equals 2. Else, screwed up Fibonacci num equals the sum of the prior 2. So when we try screwed up Fibonacci num 2, okay, it didn't like that. Block if without end if. Thought I had an end if. Oh, it is screwed up. So that's my first screw up. I had a syntax screwed up. Here's my first block, if, and maybe we're starting to see what got screwed up. Okay, so now I have taken that block and ended it. I'll do it again. Okay, it didn't do anything. I need to see the result. Okay, I got 2, which is what it should be. But what if I put in screwed up Fibonacci num 1? Oh, please don't blow up. Yep, out of stack space. And so this is the problem with doing these recursive calls. We've got to be very careful. What happened was, and we'll see what happens because I'm going to try to debug this. So if I click on debug, okay, something screwed up here. So I could put on my watch, so view, my watch window. Okay, it's already out of stack space. So what happened here? Okay, so what I'm going to do is, and it shouldn't be doing this, I'm going to see if I can message box myself. Okay, I had to do a break, so I had pushed a stop, so I'm going to try it again and see what happens. Okay, I'm trying to do screwed up Fibonacci num 1. Fine. What? I'm doing screwed up Fibonacci num negative 1? What the heck? Okay, so this is the time to try to break. Okay, it doesn't take too long to run out of stack space. So what happened here is the logic. The problem is I have if it's 1, okay, I set it equal to 1, but the code isn't over yet. Now it tries this next if block. So if n equals 2, then I have my screwed up Fibonacci number 2. Well, if n equals 1, then it's going to end up in the else. And so the first thing it's going to try to do is screwed up Fibonacci num 0 and screwed up Fibonacci num -1. And so it actually tries to do this second. Okay, it goes from right to left actually. It tries to do this second one first, second call first, and then it will do this call. Okay, I'm going to comment this out because we don't want this. Okay, so let's look at my fixed up version at the top where I've fixed the if logic. And remember, I'm letting you use this code for the assignment, but you're going to have to comment it out, and I'm going to give you actually a little bit of extra that I'm wanting to see after we talk about this. So now with this Fibonacci num, instead of doing if n equals 1 then and then end if, now I have this else if. So first it tests if n equals 1, okay? Then it tests if n equals 2, and if it's neither 1 nor 2, then it will try, okay, then it will try to do the recursion relationship. So now Fibonacci num 1 works just fine. Let me try 10. 89, looking good. 100. It's thinking. Uh-oh. This is taking a long time. Okay, so the part you didn't see was that I had to actually crash Excel. I had to force quit Excel because it had gotten caught in a really deep stack. And if you think about what happens when you try to use recursion to calculate these, what happens is you keep calculating the same things over and over and you get more and more nested things. So let me give you an example. So if I'm doing Fibonacci 100, then I'm going to try to calculate Fibonacci 99 plus Fibonacci 98. Okay, well I go back in here and it tries to do Fibonacci 98 first. Well then it's going to do Fibonacci 97 plus Fibonacci 96. Well then it's going to go back in here, try to do Fibonacci 96, etc. And then for each item on that list it's trying to expand it. So I wouldn't use recursion on this. Okay, so that was kind of a trick that I, quote, gave you the code, because this code doesn't actually work in a practical sense. It only works for very small numbers of n. But even so, it's still not complete, because if I try to put in Fibonacci num -1, it really should give me nothing back or give me an error back. And again, we get that out of stack space. So let me stop this. So really, if you're going to use this, okay, and this would count, you need to take care of the situation where n is less than or equal to 0, okay? So you need to check for that, and I'll just say return 0 for those cases, okay? So that is something to look out for. Now, let's say we actually do want to calculate our Fibonacci. So let's try it directly without all this recursion. Okay, so now I have a function I'm calling better Fibonacci num, which is going to include no recursion whatsoever. And you'll see I have 4 variables here. I'm not explaining what they are right now, and I'm not putting in all of the code, but I am putting in the important code. So again, you can use this over. I'm not uploading this file. This is checking to see if you actually watched this video. So where we have it is I have my IDX, so this is, I always use a loop variable, always have IDX, and I'm just using IDX by itself. Then I have next num, last num, and pre-last num. Okay, and I'm going to let you guess as to what these mean. I have not put all of the logic in. I've not put all of the if-thens in. You need to take care of n is less than or equal to 0 situation. Again, return 0 for those. Take care of n equals 1 and n equals 2, and you will see why for the next one. Okay, because if n is greater than 2, then I'm going to initialize my variables. Pre-last num is 1, and last num is 2. and then I'm going to loop this IDX from 3 to n. So you can see if n is 1 or 2, this next loop won't even happen. So then I get next num equals last num plus pre-last num. So here's our Fibonacci equation. And then I do this updating variables. Pre-last num equals last num, and then last num equals next num. And I want you to think about why I did it this way. Okay, why I had to have 3 variables here when I'm doing this update instead of just being able to use 2 variables. There are other ways to do this Fibonacci thing using arrays, which I have not covered in class yet, and I want to wait until I'm in person to go over arrays because that will be easier. I'm not using any new kind of code in this video. I just wanted to go over this particular homework problem. So then I loop through it, and then at the very end, remember you have to set your function equal to something, so I set it equal to that last num or next num. And so let's check that this actually works. Now I don't have it set up for less than or equal to 0, 1, or 2, so I'm not going to test those. So let's just do 3 and see that it does. Oh yes, it's 3. Yay. Let's try 10, which we could do with our recursion. Oh, 89. Nice. So let's do 100 now and see what comes back. Oh my, it's something times 10 to the 20th power. 5 blah 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 times 10 to the 20 power. That's kind of big. So we can kind of see why that recursion failed there. We had numbers that were getting larger and larger, and we had combinatorially a lot of numbers that were being calculated. It was not an efficient code. Let's say if I want to do 1,000. Ooh, that's 10 to the 208. We're getting to the limits of double precision, because if I go to, let's see, let's try 2,000. Let's see where it breaks. Yep, it breaks. And look what this runtime error is. It's overflow. That means the number got way too large, and that will happen. There are people who have to work with these combinatorially large numbers, and you can try this Fibonacci num code to see exactly where it breaks. And this is something to keep in mind. At this point in your coding, your code will likely break for stuff it's not supposed to break on at all, because you haven't programmed it right. But even when you've programmed it right, there will be something that breaks it, generally. So you need to know when you're doing real work what doesn't work. In this case, the screwed up Fibonacci num really only worked in one case, and that's when n equal 2. That's a really poor thing. For this one, Fibonacci num, it worked, the logic works, but in a practical sense, it takes forever to run once n gets even moderately large. This better Fibonacci num will work to fairly high numbers of n, and I didn't even need long because it couldn't even go up to 2,000. So that's something to think about. And notice, okay, and again, to remind you about how you declare functions, okay, you don't have to put public or private, but I put public function, then the name of the function, then whatever arguments, and I like putting what type the arguments are. And then at the very end, after you have closed the parenthesis on your arguments, the function itself needs to be typed, that you say what kind of result comes back. Otherwise, it's going to be type variant. And I don't like that. I like all types declared. When you don't have to use variant, you need to declare your types. You definitely needed to use double. Even though these were supposed to be integers, they're way too large even for long integers. You would need to create a new data type to get as large to do the 2,000th Fibonacci num. So that's something to think about. When I get to class on Tuesday, I will continue to go over these homework problems. I know this is somewhat difficult. The next assignment I'm going to give you is going to be a lot simpler in terms of we're just going to work with Excel objects. I'm not going to have a lot of logic involved, so it's just going to be testing that you can manipulate the Excel objects with VBA, and that's it. I know this is conceptually difficult, but we'll work through this, and this is why I'm giving you a lot of the code to test out. And a lot of times in real work situations, what you're going to do is take someone else's code and then modify it for the uses you want. And so that's really what I'm trying to get at, is so that you could read somebody else's code, make some minor modifications so that it does what you want it to do.